fiber optic communication works. And you can see here we have a fiber optic cable with smaller little bundles in there, and then inside of those bundles are smaller little tubes. So let's read about fiber optic cables. As far as we know, nothing moves faster than the speed of light. In a single second, light can travel all the way around Earth 7.5 times. Because of its incredible speed, light can be used to transport information in an instant. One way of using light to carry information is through fiber optic cable. Fiber optic cable is made of long, thin strands of glass about the width of a human hair. These strands are made of very pure glass that reflects light well and are covered in a protective coating. Light bounces along the inside of the fiber optic cable at the speed of light, making fiber optic cable the fastest possible way to get information from place to place. One fiber optic cable can transmit information about 100 kilometers or 60 miles. After 100 kilometers, there's a device that receives the signal traveling along the cable and retransmits it along the next cable for another 100 kilometers or 60 miles. How can light transport information? First, let's look at different ways a specific kind of information, your voice, can be transported. When you are talking to your friend and she is standing right next to you, your vocal cords create a sound wave that travels through the air into your friend's ear. But what if your friend is far away? Before cell phones and fiber optic cables, the only option was to talk to your friend on telephones connected by metal wires, what we now call landlines. If you talk on a landline phone, the phone changes the sound wave of your voice into an electrical signal that carries the information from the sound wave. As the electrical signal travels along the wire, it loses power and picks up noise. Noise is when a wave gets changed little by little as it travels. When the electrical signal reaches your friend's telephone, it gets changed back into a sound wave, but the noise is now part of the wave. This isn't a problem for short distances, but over long distances, the noise can sound like static in your friend's ear. A better way to transport information over long distances is by sending light through fiber optic cables. The information carried by light takes the form of a digital signal. Sound waves and other kinds of waves are not digital, but they can be converted to digital form. To convert sound wave created by your vocal cords to a digital form, a device measures the height of the wave a certain number of times per second. It records the height of the wave at each moment as a number. When it's time to recreate the wave, those numbers can be used in the right order to produce a wave with exactly the same heights at exactly the same places in the wave. That is, it will be nearly exactly the same wave that was recorded. A wave that has been digitized can be played back as a wave over and over, and it will be the same every time. For that reason, digital signals are a very reliable way to record information. As long as the numbers in the digital signal don't change, the information can be reproduced exactly over and over again. To make a digitized signal into something that can be transmitted by light, all those numbers are converted again into a pattern of light flashes, wave pulses. Each pattern of flashes represents one number in the signal. The pattern of light flashes is sent along the fiber optic cable by a laser that can flash very quickly, hundreds of times per second. When the flash of light are received on the other end of the fiber optic cable, they are converted back into numbers and then back into sound waves we can hear with our ears. This means your friend won't hear any static, even if she's halfway around the world when you talk to her. So if we scroll down, this image looks like it talks about the noise involved with waves. So we have the original sound wave, which is nice and clean, a good clean line. Then there's noise, which is interruptions. And so the sound wave with noise, instead of being a nice clean line, it's jagged, and there will be static and crackling in that sound. So we scroll down, it shows a fiber optic cable. This is the inside of a fiber optic cable. So there's reflective glass along the inside with a protective coating around the outside. And the light comes in and it bounces and reflects off the glass. So it continually just bounces back and forth, always heading in a single direction. And it travels down the tube incredibly quickly because light is the fastest thing in our universe.